Hello world. So these are CS50's office hours, and if you've not joined us before, this has been an opportunity over the past few months for us to spend some time on campus answering your questions here live via the internet. So I thought I'd give you a quick tour of some of the buildings outside and inside of which I spent quite a bit of time when I myself was in graduate school, because indeed we're outside the original buildings of Harvard School of Engineering and Applied Sciences, but we're also around Harvard Law School. So come on and take a look. So over here to your right is Jefferson Hall, which is actually the physics building on campus. So graduate students and undergraduates would spend a lot of time in this red brick building doing experiments, taking classes, and the like. That connects to another building over there, also in red brick, called Cruft Hall, which is connected. So you might be able to pass from one building to another very easily going between classes. And if you look over my shoulder there, there's sort of a weird bridge that's connecting what is Cruft Hall and the building to its left, which is Pierce Hall, which is actually one of the earliest buildings in Harvard School of Engineering and Applied Sciences. It's been there for so very long, and indeed it's likely to be renovated in the coming years to actually make it all the more accessible to students, faculty, and staff alike. But that bridge connects just a couple of the floors. And now behind me and way back there, with a lot of glass and stone, sort of in white, in between all of these brick buildings, is Maxwell Dworkin. And so that's the computer science building where I myself and a lot of my colleagues and friends spent time in graduate school, and more recently did undergraduates as well. But the engineering school actually moved all the way across the Charles River, which is a large body of water that cuts between Cambridge and Boston, Massachusetts. So most of the activity, engineering-wise, on campus is over there nowadays. But lastly, before we have a seat, on your left is Langdell Hall, which is a beautiful, large library for Harvard's law school. And in fact, if you've seen any of the videos, introductory or otherwise, from CS50's Introduction to Computer Science for Lawyers, CS50's own Doug Lloyd and I actually filmed that class inside of one of the most beautiful rooms in that building there. But why don't we go for a quick stroll, and we've got a picnic bench lined up for us today. And if you'd like to start asking questions via the chat, we're happy to answer any and all of your questions about CS50, computer science more generally, Harvard, indeed, on this next step on our tour. Well, wait a minute. Who do we have here for the internet? Looks like we have CS50's own Brian Yu and Carter Zenke.
Hey, everyone. Nice to meet you.
What a pleasant surprise to see you out here with a microphone, no less, today.
So I have a few questions for you, David, and also for you, Brian. One of which is, if someone wants to start learning computer science, what mathematics should they perhaps know? Maybe go first to David and then to Brian.
Oh, that's a good question. So I generally, when you're diving into introductory computer science, like something like CS50, honestly, definitely having comfort with arithmetic, addition, subtraction, and so forth makes sense. And also a little bit of comfort with algebra, so that you can understand symbolic manipulations with things like x's and y's and z's, or notation like f of x and the like. But beyond that, that's really all you need to get your foot into the door. But when it comes to higher level classes in graphics, machine learning, I think more math would indeed help.
Yeah, definitely. I think a lot of the more interesting developments in artificial intelligence recently are very much based in mathematics, but you don't need that level of mathematics just to get started or just to try programming for the first time. Just basic familiarity with algebra is helpful, as is a little bit of logic, like if this and that are true, what else might be true, and starting to think about that type of thing, but nothing formal necessarily.
And if I can ask a question of Brian, who you haven't seen as much of over the past couple of years. Brian, what have you been up to?
Well, after I was done working at Harvard full-time, I started working in software industry. So I've been programming at larger software companies and smaller software companies alike. But I always definitely enjoy being back at Harvard and working with the CS50 team whenever I can.
Yeah, and still teaching. His course is offered not only through edX, via which you might have discovered Brian's class on AI and web programming, but also through Harvard's Extension School, where adults of all ages can actually pursue credit and degrees through a more traditional structure, TAs, deadlines, and more.
And Brian, I know when folks go to industry, they're always still learning. And so I'm curious, is there, maybe one thing you've learned this past year that you didn't learn in prior years?
Yeah, absolutely. I feel like the technologies are constantly changing. There are new developments in languages. Recently, I've started picking up Rust as a programming language that I've had a lot of interest in. It's gained a lot of popularity in recent years, and it has some nice benefits of a low-level language like C without having to deal with some of the memory-related bugs that you might have encountered if you've worked through any of the memory problem sets in C. And so learning new languages, learning new technology is one of the nice things about working in software is that there are always new things to learn.
And actually, on that note, one of the questions we often get from students online is about languages like Rust and Go and sort of the flavor of the week, so to speak, because it seems to me very frustrating if you spend all of this time, all of this struggle trying to learn C or Python or Java or C++, and then you have to go and learn something else. And can you perhaps speak to that tension between learning's foundational material, but also having to keep up with it?
Yeah, absolutely. I think learning a new language gets easier over time. That once you know one programming language, many programming languages draw inspiration from each other and are based on similar ideas. So the things you learn in one language definitely apply when you're going to another language and trying to apply that. And what's interesting is looking at how different programming languages try to solve problems from previous programming languages. Like a language like C gives you a lot of control over memory, but it introduces potentially bugs if you're not careful about freeing memory when you're done using it, if you're not careful about accessing something in an array when the array might not have that many elements, or accessing null values. And so different languages have made different choices to try to make those kinds of errors less likely. And so I find it interesting to learn something new and learn how it can solve a problem that I was running into in a language I was using before.
I can't help but make a joke. There's been a bug. You have a bug, like that's been. Haha. Okay, all gone.
Thanks.
Okay.
So I guess I'm curious, Brian. You said you were learning Rust. What kinds of problems does Rust solve that other languages might not be able to solve themselves?
Yeah, a lot of it is around memory safety and type safety. So type safety, if you're working with a string, like text, for example, and you try to add a number to it, not all languages are going to handle that very well, and it might run into problems if you think something is a number and you try to add something to it and it runs into a problem. And so languages that have strong type systems, languages like Rust, are pretty good at trying to catch those kinds of problems early, so you can avoid making that kind of mistake, and you'll be notified if you do make that kind of mistake. And the other big benefit is around memory safety, that the types of memory issues that we often run into in lower level languages like C can be frustrating to deal with and frustrating to debug. And so if we can make decisions in the programming language that make those easier to debug or harder to have problems come up in practice, that can definitely be helpful.
So why is it, would you say, that languages like Python are so popular, which doesn't have types, or really it's more dynamically typed, so you don't have to specify in advance, like in C, in CS50, what the type is?
Yeah, I mean, Python is still my go-to language if there's something I need to do quickly, and I think one of the benefits of a dynamically typed language like Python is that you can write very little code to get a lot done, and sometimes something that takes only a couple lines of code in Python is going to take many more lines and much more time to write in a different programming language, and so there are trade-offs between all of these. No one language is necessarily always better than the other. You have to figure out what's your use case, how often are you going to use the code, are you going to have to maintain the code later. All of that might contribute to your decision about what language is the right choice for the thing you're working on.
And maybe to preempt one question, like in CS50P, CS50's Introduction to Programming with Python, we introduced type hints a little bit in Python. Does that solve the problem you're speaking to, that Rust also solves?
It's related. Definitely adding type hints helps to make clear what types you're expecting and what you're dealing with. And different languages will have sometimes stronger or less strong safeguards when it comes to what types are okay and how they can interact. And so Rust is just a little bit more strict about trying to prevent more types of errors, but Python type hints I definitely find are helpful too. And often when I'm writing larger code bases in Python, adding those type hints is definitely useful just for signaling what's types are we dealing with and how can I avoid making those kinds of mistakes.
Nice.
And if someone's just starting out and they're trying to figure out what language they should begin learning, like you mentioned, it all depends on the context, but I'm curious, let's say someone knows a problem they want to solve, what kinds of aspects of that problem should they care about to help them inform what programming language they should learn, if that makes sense?
Yeah, so are you asking about like if you're first learning programming having not known any languages?
Exactly.
Or okay. I think in that case, I do like CS50's approach of starting with C, which is not an approach that a lot of programming courses take nowadays. But as David and I have talked about before, it's very helpful to really understand the fundamentals. And C, nothing is given to you for granted. If you want something, you need to implement it yourself. And so that really helps to give you a good understanding of the basics of programming, the fundamentals of how the computer works and how to interact with it. But in practice, if you're going to build a web application nowadays or a mobile app, you're probably not going to write it in C. You're probably going to write it in one of the languages that allows you to build those things a little more easily and gives you a little more out of the box.
This is a debate I still have with colleagues of mine, especially at other universities. Like when we go to conferences in the computer science education space, who are wondering why do we still teach C since so many other classes have moved on to Python or Java or the like. But I think for exactly this reason of sort of building up from the ground up and giving you and us sort of a bottom-up understanding of how all this stuff works.
And when someone's learning a new language, like there's probably a lot to learn procedurally, as in like how to solve a particular problem. But there's also some memorization involved, like the syntax of a language. And so I'm curious, do you have tips for folks on how to memorize things faster when it comes to computer science?
Interesting. And I'm hearing from the folks online, we should probably talk a little louder into our mics.
Sure.
Learning faster. Honestly, I feel like AI is going to be the solution to that because autocomplete is about to, if you haven't experienced it yet, get a lot better. And honestly, I mean that largely seriously because VS Code and similar text editors and full-fledged IDEs for years have been able to autocomplete certain things so that if you at least remember the name of the function but not its arguments, you can very quickly see like a little pop-up that sort of guides you to the solution there syntactically. I think even more so now with tools like GitHub Copilot, which is a full-fledged AI tool, which doesn't just deterministically autocomplete something you're typing, but it rather suggests multiple lines of code that might be where you're going logically, honestly will just help with a lot of that struggle with a lot of the syntax and specifics of a language, because it'll just kind of show you with high probability what it could be or should be that you want to type. But maybe a more educational answer might be from Brian here.
No, I like that answer a lot. I think that makes a lot of sense. And honestly, some stuff you will not end up memorizing. And one of the nice things about having the internet at your disposal is that if there's something you need to know, it's very easy to look it up and find out. And so I think a lot of getting comfortable with a language just comes with practice and using that language a lot. But definitely once you start learning multiple languages, every language has a different way to take some text and make it lowercase, and the way you do that is different all the time. And so it's easy to get those confused. And so that's where autocomplete, where looking something up can be helpful, because realistically you're not going to memorize everything, and that's okay.
And realize too, it's relative to the language. Like one of the first languages I learned after C was Perl, and oh my God, like even after all these years, I still don't know how to read Perl code sometimes because there's such clever syntactic tricks that you can use to solve problems. I kind of feel like Ruby is a little bit like that, which I don't know very well, but we've had to use a little bit, and I'm always trying to Google the syntax, but it's really hard to Google syntax because search engines tend to ignore weird things like punctuation, and so it's hard. So I empathize too.
I think it's still a worthwhile goal to memorize like the core features of some language. Like when you're working and you need to look something up, that kind of cuts out your flow as you're working on some problem. So it's probably worthwhile to learn those core features, and beyond that, probably turn to the internet for extra help.
Yeah, for sure.
All right. So maybe a related question is, someone says they're facing difficulties learning pointers. What kinds of pointers could we give them to help learn about pointers?
That one just takes time, I think. Honestly, and the tale I tell in CS50 sometimes is that I still remember 25 years later where I was on this campus the day that I finally got pointers. I was in the Elliott House dining hall, so one of the undergraduate cafeterias. I was in the back right corner. I was talking to my TF, Nishat Mehta, who was my very first computer science TF, and he very kindly spent a little more time with me that day, walking me through some of my questions, much like you might have. And for some reason, it was that 10th, 11th attempt of trying to understand them that the light bulb finally went off for me. That said, I do think looking at things in pictures or finding in textbooks or online references representations of what's really going on with pointers can really actually help. And we try to do a bit of that in CS50, but surely focusing on visualizations, if you can find them online, might help further.
Nice. And maybe a question for Brian. So in industry, I maybe guess, I assume you have to learn a new framework as you transition. Is that true, would you say?
That can often be true. There are a lot of different frameworks for building web applications or mobile applications or whatever it is that you're designing. And so sometimes when you enter a new job in industry, you might be asked to work in a framework that you're not familiar with before. And so that's where relying on your past knowledge, figuring out how to apply it to a new framework you might not have seen before can be helpful. Reading documentation, looking at examples, the same types of things you do when learning a language for the first time, you can often use when looking at a new framework for the first time.
And for those who aren't familiar, could you define what a framework actually is?
Yeah, so a framework, well, depends on the context, but often it's a bunch of code that's already been written that helps to make it easier to solve some problem or create something. And so a lot of my experience is with web application development, and so there are a lot of different web frameworks, a bunch of code that's already been written to handle what do you do when you get an incoming web request, and how do you look at the data that's in the request and send back a response and have different templates for the responses. And so that code is usually not the interesting code that you want to write. You want to write the code specific to your web application. And so the framework takes care of a lot of the stuff that's common to a lot of different web applications, leaving you to be able to focus on what's most interesting to your project.
And maybe to make this real for folks less familiar, like in CS50X, you might recall that we introduced Flask toward the end of the class as a micro framework. But in CS50W, which is Brian's introduction to web programming with Python and JavaScript, you use Django. And do you mind distinguishing something like Flask and Django for folks, both of which I think are really frameworks?
Yeah, Flask and Django are both Python web frameworks. So you use the Python programming language to build a web application, and both of the frameworks give you some tools out of the box to help you do that. Flask is a much smaller framework. It does the basics of handling requests, letting you route requests to the right place depending on what comes after the slash that the user types into the URL when they're visiting a website. Django is a much more full-featured framework. It adds features like giving you database models if you want to keep track of information in your database, and the structure of that database might be evolving or changing over time. It lets you keep track of changes to that over time using a tool known as migrations, and it gives you a lot of features for administrators to go into a web application and make modifications or changes to the data, and helps to give you some more control over the way that requests are handled over the internet. And so if you need some of those more advanced features, Django can be very useful at just helping you build an application more quickly. But Flask is definitely in use by a lot of web applications. I think it's a great Python web framework, and I definitely use it too.
Yeah, and one of the reasons we use it in CS50X, particularly since we only spend a few weeks on web programming, is that it is like micro framework. Like it only does what we want it to do without you having to learn an entire framework unto itself. In CS50, we can largely focus on Python itself.
And let's say someone's an aspiring programmer, they want to be, a great computer scientist. Would it be worthwhile for them to try to create their own framework, or should they maybe learn something else that's out there?
This is why the world has so many frameworks and libraries, because reasonable people will disagree. I mean, developing your own framework, I think, would be the solution to a problem. If you, in your own projects or in your professional pursuits, think that Flask and Django or Laravel in the PHP world or any number of other frameworks, .NET, aren't quite doing for you what you want them to do, then sure, you could consider building out your own framework. The catch is that certainly in industry, that's probably not the best use of time, because you would spend so much time reinventing a lot of wheels just to make arguably marginal changes that it might not really be the best use of your time if it detracts from actually building your tool, building your product, building your personal project, whatever it is. And so I think that's the tension, and that's why I think you tend to see that only a few frameworks within each ecosystem tend to stand out, because there's a lot of great ideas. I'm sure there's a lot of great micro and otherwise frameworks like freely available on GitHub, but they end up falling by the wayside because people just underestimate perhaps, or just don't have the time to put into it.
The other thing I would take into account is security. There are a lot of security concerns and vulnerabilities on the internet, and one of the nice things about using a framework that's been developed over a long period of time, well tested by a lot of different people, is that people have been able to identify a lot of those security vulnerabilities, and they've been able to be fixed too. And so if you're building a framework on your own, those kinds of security concerns are definitely something you need to be thinking about, and there's a lot of potential security problems. And so from a safety perspective, it's often safer to use a framework that's been well tested over a long period of time and where these vulnerabilities have been looked at already. But I think it can be a good exercise if you're interested in understanding a little bit more about what goes into a framework to try to build one. But I definitely use caution before taking a framework you've built yourself and using it out in the real world.
Yeah, case in point, CS50 has its own Python library, which was meant to be a pretty small library that just ports from C to Python some of the functions that we use in the beginning of the class, like getInt and getFloat and the like. But over time, we added a bit more functionality to it, specifically for SQL, so that within CS50X, you can use a function called execute that just handles the whole process of letting you execute selects and inserts, deletes, updates, and the like, and it just simplifies the use of SQL. And yet, over time, even though this was was a nice idea. It wasn't a very complicated implementation. We realized, oh my gosh, like there's this corner case, or oh my gosh, it needs to work now with SQLite and MySQL and Postgres, and oh my gosh, there is this security issue here. And it's become a massive file that was never our intention, and so much pain to chase down all of these bugs. And it might have, in retrospect, been a lot better just to use something off the shelf rather than thinking we can do this better.
And a follow-on question here from Abood, who's asking, is it worthwhile to learn data structures? Which I think is actually an interesting question now, because there are so many frameworks that give so many things to you, like off the cuff. So is it worthwhile to learn those underlying details still?
I definitely think it is useful to have an understanding of data structures and having a sense for which data structure is the right choice for the problem that you're trying to solve. And that might be simple data structures, like in Python, for example. There are some common data structures are lists and dictionaries and sets, and each of them have their different trade-offs. Some of them are faster at certain types of things and slower at other types of things. And so if you're going to start storing more and more data, you want your project, whatever you're building, to be efficient, ideally. And so having a sense for what data structure is the right choice, that can definitely be helpful. And then as you start getting into larger and larger projects, if you think on the scale of companies that are storing massive amounts of data, then they really need to think about how are we going to store this data in a way that's going to work, in a way that's going to scale well as we get more and more data, in a way that's going to be efficient. And so thinking about things like big O notation, which you're introduced to in CS50, to think about what is the performance of these data structures, that definitely has value.
Yeah, and I would be even blunter, like why wouldn't you? Like if you want to be a programmer or if you want to be a computer scientist, like these are tools in your toolkit, like data structures and algorithms and mathematical models that Brian alludes to. And so like that's all of the ingredients that's gonna make you better at your job, at your personal projects or the like.
And let's say someone takes this advice to heart, they want to learn all about data structures. What course should they take then?
No. So CS50 does touch on a range of data structures, not in great depth, but week 5 of CS50, if you're already taking or planning to take CS50, I do think is a very good introduction to the range of options. And by data structures, we mean things in simplest forms like arrays. Those aren't really data structures, but that's about as basic as you can get. We introduce things called linked lists, but they're singly and doubly linked lists. We introduce hash tables, which is sort of an amalgam of arrays and linked lists. We talk about trees and tries and other structures, but you could spend much more time on data structures and algorithms. DSA is often what CS people might describe it as. One of the algorithms class, which does touch on data structures, is something from Princeton. If you look for Introduction to Algorithms on Coursera.org, you should be able to find a free class from our friends there. And Brian, do you have other?
That was the one that came to mind, actually, too. I think there are also a lot of good online, not necessarily courses, but online references and books. Even Wikipedia is a good place to start if you're curious about, like, what does this data structure do and how does it work? I found that Wikipedia is often a good first place to look just to understand the basics of the data structure. And so I think any of those are definitely good places to get started.
Yeah. And switching gears a little bit, we got a question from the audience.
These questions just in. Thank you, Max.
There's some new questions here, so I'll scroll through these and find some. One off the top, though, that I saw from earlier, just to switch gears a little bit, is why is it 50 and not, let's say, 33?
So at Harvard here historically, the second to last or penultimate digit of a course's number has indicated what type of class it is. So in the case of CS50, the second to last digit, 5, indicates that it's a software class. Meanwhile, there's a class at Harvard that's not freely available online called CS61, whose second to last digit is 6, of course, and 6 indicates a systems class, so a lower level type class. There's a class at Harvard called CS171, which is all about visualizations and visualizing data through graphics. That 7 indicates that it's indeed a graphics class, and something like a 2 is theory, something like a 3 is economics, something like 8 is artificial intelligence. And so it's been historically at Harvard a bit of a clue as to what type of class something is. So CS50 simply inherited that system. Nowadays, though, as of a few years ago, Harvard has so many classes now that we actually reinvented the future numbering scheme, so that system won't necessarily bear out in the coming decade or two.
And not quite related, but still I think a good question here from Sandesh, who may be for you, Brian, is asking, how can a person land a job in a particular domain after completing the relevant course without a degree, given you just transitioned to industry a few years ago?
Yeah, it's definitely possible to get a job without having a degree if you've either self-studied or other ways that you might have learned the tools that you need in order to be able to do the job. I think A lot of what employers are looking for is the kinds of experiences and that you have, and understanding that you have the ability to, once you start the job, to be able to build what it is they're looking for you to build. And so to that extent, once you've taken some classes, I think one of the best ways to get started is to try building something of your own. So at the end of CS50, you build a final project of your own that you choose something you're interested in and use the tools you've learned in the class to build it, and continuing to do things like that, building projects of your own, continuing to build on existing projects. That helps you to get the experience you need to be able to be successful in industry setting. And after that, I think it just ends up being a lot of work to apply to places, try to find something that matches your interest and your experience level. And that can definitely take time, it can definitely take patience, but having that practice of having built things on your own, that's definitely helpful.
And maybe you're in a current job and there are some problems that you could solve using computer science, using your skills you learned from CS50. Like when I managed the course, there's a lot of scripts to help manage that course and help do things more efficiently. So you could think of the same. Like what could you automate in your current job as well?
Yeah, and therefore in interviews, on your resume, being able to speak to those kinds of projects says a lot, and even more, dare say, than just saying you took this class, and this class, but speaking to your actual experience. I think we have time for a few more questions.
Sure. So one that is a pretty easy answer is, when is the cybersecurity course coming out, David?
October 1st on edX.org. If you go to cs50.edX.org/cybersecurity, all that and more will await. And I would be remiss if I didn't plug Carter's Introduction to Databases with SQL class, which is coming when?
October 1st.
Wonderful. At cs50.edX.org/SQL.
And that actually answers the next question, which was, when is SQL coming out? So October 1st.
Oh, wonderful. And you know, Brian, I hear that there's actually a somewhat new version of CS50 AI, if you might speak a little bit about that.
Yeah, absolutely. So the original CS50 AI is about 3 years old now, and in these past 3 years, a lot has developed and a lot has changed in the world of artificial intelligence, especially as it concerns natural language processing and about AI that's able to generate text, that's able to understand human language, and developments in the tools and technologies that we use in order to do that. And so we have a new version of CS50 AI that includes some updated material about natural language, and so that is at cs50.edx.org/AI.
And for those folks who might have taken CS50 AI already but want to get the new stuff, which week should they focus on?
It's just the last week, so week 6, which is all about natural language processing and language in general.
Nice. Maybe one or two other questions?
I think that actually brings us to the end of the question I'm seeing on Instagram here.
Okay, nice.
So any final words from you all?
Oh, words of wisdom, Brian.
Words of wisdom. I think computer science in general, there's so much to learn, and so my encouragement is always to keep learning, to try taking a new class, to try learning something that you've been interested in that you just don't know much about right now. And so my word of wisdom is to keep trying to acquire that wisdom, keep learning.
And if you have questions too about CS50 or any of its courses or computer science more generally, you can now try out, as you might have seen online, the CS50 Duck, which is an AI creature that you can ask questions of about problem sets, about material more generally. The easiest way to access it is to go to cs50.ai, and you can log in with your existing GitHub account, or if you don't have one, you can sign up for one for free at github.com. And if you're also in the habit of using cs50.dev, which is CS50's own implementation of VS Code in the cloud on top of a product called GitHub Codespaces, that also has support for the duck. In fact, if you look at the activity bar along the left-hand side, you should see now a duck icon that does not just quack, quack, quack at you, but will actually answer you primarily in languages like English. So try that out too for your next questions.
All right. Well, thank you all for joining us over Instagram Live. We'll see you next time.